Hello, ladies and gentlemen. Welcome to your first flipped lesson. Just keep in mind at any point during this lesson, if I'm going too fast, that you can always hit the pause button and stop and go back and forward wherever you need to go to stay with me, okay? Take good notes. Make sure you write down any questions you have for me so that we can go over them tomorrow in class. Today we're going to be doing multiplying and dividing fractions and mixed numbers. These are the rules for when we multiply fractions and mixed numbers. The first thing we need to keep in mind is if we have any mixed numbers, you have to turn them improper before we can multiply them. We also need to simplify any factors. If there are factors diagonally, we're going to do what I call cross-canceling, and I'll show you what that is in just a minute, but keep that in mind. We're going to be simplifying all factors. You multiply numerators by numerators, and you multiply denominators by denominators. Keep in mind this is very different than when we learned how to add and subtract. When we added and subtracted, we need to define that common denominator. You're not going to need to do that when you multiply and divide. And when you multiply and divide, your denominator is not going to stay the same. You will multiply it. The last step, as always, is to simplify if you have an improper fraction to make sure that you put it into a mixed number. We're going to start by looking at a multiplication problem. Anytime you have a whole number, we're going to turn it into a fraction. The way that we turn it into a fraction is we put it over 1. Okay? The next step is to look at your diagonals. When we look at our diagonals, we want to see, is there any factors where I could cross-cancel? In order to do that, we say, is there a number that can go into both 7 and 5 evenly? Since there's not, and there's not a number that's going to go into 1 and 1 besides 1, which is not going to help us, we're ready to multiply straight across. We need to keep our negative rules in mind. When I multiply a negative times a negative, I'm going to get a positive. So when I multiply 7 times 1, we get 7. When I multiply 1 times 5, I get 5. When I have a larger number in my numerator, this is called an improper fraction. We cannot leave it like this. We need to turn it into a mixed number. In order to do that, we're going to divide. How many times does 5 fit into 7? Well, it fits in there one whole time, but there's still 2 left over. That 2 is going to become your numerator, and your denominator always stays the same. So we end up with 1 2/5. Keep in mind it's positive because a negative times a negative is going to give us that positive number. On this one, same thing. We're going to start by looking at our diagonals. Is there a number that can go into both 4 and 7? Since there's not a number that's going to evenly go into both 4 and 7, we're ready to look at our next diagonal. Is there a number that can go into both 5 and 5? 5 can go into both 5 and 5, so we ask ourselves how many times? How many times does 5 fit into 5? Since it fits in there one time, we cross this out and we make it a 1. Same thing here. How many times does 5 fit into 5? 5 fits into 5 one time, so we're going to cross that out and we're going to make it a 1. Now I'm ready to multiply. First thing, when I multiply a negative number times a positive number, I need to ask myself, am I going to get a negative or positive answer? Since I know I'm going to get a negative, I'm going to start by just putting it out there so we don't forget it later on. Now I'm ready to multiply my numerators. 4 times 1 is 4. 1 times 7 is 7. Next step is to check if it's simplified. Since this is completely simplified, we can't reduce it any further, and I don't have a mixed number, that's our final answer. We're going to go ahead and circle it. On a problem like this where I have a mixed number, my first step is going to be to turn that mixed number into an improper fraction. 3 times 3 is 9. 9 plus 1 is 10. Keep in mind that your denominator always stays the same. Keep in mind whenever you have a whole number, we're going to rewrite that as 9 over 1. It's the same thing. 9 divided by 1 is the same thing as 9. Now I'm ready to go to the next step, which is cross-canceling. I'm going to look at my diagonals and I'm going to ask, is there a number that can go into both 9 and 3? Well, there is a number that can go into both of them, 3. How many times does 3 fit into 3? One time. So that's where I cross out the 3 and I make it a 1. I do the same thing in my numerator. I say, how many times does 3 fit into 9? Since 3 fits into 9 3 times, I'm going to cross out that 9 and I'm going to make it a 3. I'm ready to multiply straight across. I don't have to worry about negative numbers because everything is positive. 10 times 3 is 30. 1 times 1 is 1. I can simplify on this one because keep in mind a fraction is always just a division problem. So on this one, when I look, can I do 30 divided by 1? Since I can and I know the answer is 30, we're actually going to go ahead and divide that out and we get 30 as our answer. Looking at this one, same thing, I'm going to have to turn that mixed number into an improper fraction. So I'm going to bring this negative 3/10 down. I'm going to bring down that times sign. 2 times 2 is 4. 4 plus 1 is 5. So I'm going to rewrite that as negative 5 seconds. Now I'm ready to look at my diagonals. Is there a number that can go into both 3 and 2? There's not a number that's evenly going to go into both of those, so I'm going to look at my next diagonal, 5 and 10. I can look at that and see that 5 fits into both 5 and 10. How many times does 5 fit into 5? Once. So we're going to change that 5 into a 1. We're going to do the same thing down here. How many times does 5 fit into 10? Twice. So we're going to change that into a 2. Now I'm ready to multiply. So I'm going to look, I have a negative times a negative. When I have a negative multiplied by a negative, we know we're going to get a positive answer. 3 times 1 is 3. 2 times 2 is 4. So that's how we end up getting 3/4, and we know that that is a simplified fraction. The next thing we're going to be looking at is dividing fractions. Keep in mind if you need to pause this, if I go through this slide too fast, just keep in mind you can always hit pause. When we divide fractions, it's actually very similar to multiplying fractions. The first thing we need to do is the same thing we did for multiplying fractions. We're going to turn them into improper fractions if we can. If we have mixed numbers, we're going to go ahead and we're going to change those into improper fractions. Instead of dividing, we're actually going to change the problem. We're going to be multiplying by the reciprocal. So anytime you have a problem with division, we're always turning it into a multiplication problem, which we just learned how to do. So what you need to do is you're going to keep the first fraction exactly the same. That's why I have keep here. We keep that fraction the same and we don't do anything to it. The change is talking about your sign. Instead of dividing, we're turning it into a multiplication problem. So we're going to keep our first fraction, we're going to change our division to multiplication, and we take the reciprocal of the second fraction. What that means is we flip the fraction. Multiplying by the reciprocal is the same thing as dividing. For example, when we multiply by, let's say, 1/2, that's the same thing as dividing by 2. So that's all we're doing is we're just kind of putting it into a multiplication problem and going backwards. Again, we're going to cross cancel, so we're going to factor out these problems if we can. Looking at this first one, negative 1 and 1/9 divided by 6 2/3. The first thing we're going to do on this problem is we're going to take our mixed numbers and we're going to go ahead and turn those into improper fractions. So looking here, 1 times 9 plus 1 gives us 10. So we get negative 10/9. We're not ready to change yet, so bring that division sign right down, okay? What's 6 times 3 plus 2? We get 20 over 3. Now I'm ready to do my keep, change, flip. You'll hear me refer to it in class sometimes as KCF. I might even say Kentucky Chicken Fried. It's kind of backwards because usually it's Kentucky Fried Chicken, but it's just one of those things that helps you remember. Kentucky Chicken Fried is keep, change, flip. So that means we always keep our first fraction the same. Nothing is happening here. You bring down your negative sign, you bring down that 10 and that 9. Division is your change. We need to change that division into multiplication. The last step is flip, which means we're taking the reciprocal of 20/3 and we're making it 3/20. Now this is a problem like you just learned how to do. We're ready to look at our diagonals and see if we can cross cancel anywhere. Is there a number that goes into both 10 and 20? Well, 10 fits into both of those, so I'm going to cross this out. How many times does 10 fit into 10? 1 whole time, so I'm going to make that a 1. How many times does 10 fit into 20? 2, so I'm going to make that a 2. We're not done because I have to look at my other diagonal. With 9 and 3, I know that 3 fits into both of them. 3 fits into 3 1 time, so I'm going to cross out that 3 and I'm going to make it a 1. 3 fits into 9 3 times, so I'm going to cross out that 9 and I'm going to make it a 3. Now I'm ready to multiply. I have a negative times a positive. Whenever I have a negative times a positive, I know I'm going to get a negative answer. 1 times 1 is 1. 3 times 2 is 6. The great thing about cross-canceling is it saves us a lot of simplifying at the end. If we didn't simplify this and we just did 10 times 3, we'd get 30, and 9 times 20, we'd get 180. That's fine, but it's a lot more simplifying at the end, where we can just simplify it right away. Looking at this one, negative 6 and 2/5 divided by negative 2 and 2/7. Same thing, we're going to start by taking these mixed numbers and turning them into improper fractions. 6 times 5 is 30. 30 plus 2 is 32. Bring that division sign down. We are not ready to do keep, change, flip until you already have your fractions as improper. Bring that negative sign down as well. 2 times 7 is 14. 14 plus 2 is 16. So bring down that 16/7. Now looking at this problem, I'm ready to go ahead and do my KCF. Kentucky Chicken Fried. Keep, change, flip. Okay, that first fraction is going to stay exactly the same. Nothing is going to change there. Bring down that negative 32/5. Your division sign, that's your change. Every time we're going to change our division into multiplication. The last step is to flip the fraction, which again, that means we're taking the reciprocal. Okay, we are multiplying by a negative 7/16. Now I look at my diagonals. Is there a number that can go into both 7 and 5? There's no factor that will fit evenly into both of those, so we're going to look at our 16 and our 32. We want to come up with the biggest number that will evenly fit into both of them. I know that 2 fits into both of them. I know 8 and 4 both fit into them. But the biggest number that fits into both 16 and 32 is 16. So we go ahead, 16 fits into 16 1 whole time, so we're going to cross that out and make it 1. 16 fits into 32 2 whole times. So we're going to cross that out and make that a 2. Next thing is we have a negative times a negative. A negative times a negative we know is going to give me a positive. So I don't have to worry about bringing my negative sign over. I can just concentrate on multiplying my numerator by my numerator. 2 times 7 gives me 14. 5 times 1 gives me 5. I know that I can't leave this like this. When I have a larger number in the numerator than the denominator, that's where I have an improper fraction. I can't leave it like this. What I need to do is put it into a mixed number. So again, we're really doing division. How many times does 5 fit into 14 without going over? 5 fits into 14 2 whole times, but 5 times 2 is just 10. We need to get all the way to 14, so that tells me there's 4 left over. That becomes your numerator, and your denominator stays 5. Your answer is 2 4/5. Keep in mind, we're going to be practicing with this a lot tomorrow in class. Make sure you write down any questions that you have. Please make sure you're practicing these and solving them with me. If you need to go back and redo, or if you're confused about one of them, make sure you write it down. And I'm really looking forward to seeing you all tomorrow. If you didn't understand, make sure you ask. Thanks.